Good morning. We are going to continue solving equations with variables on both sides. But for today's equations, you're going to not quite get an answer in the end. You're not going to get x equals for some of them. Some of our answers are going to be no solution or all real numbers. So when you think about solving an equation, you should think about this as like a treasure hunt. You need to find the value of x. However, you're going to notice today that there are equations where the solutions are different. When you solve an equation today, you may find that the equation doesn't quite look the same when you start solving it. You're not going to be able to find the value of x. So what happens then? Well, what happens is that your solution is going to be a special case. It's either going to be that there is no solution or that all real numbers is a solution. And I know this might seem really confusing right now, but let's take a look at the special cases that we are going to see today. So when we solve a problem like that we've used to solving, we always got a solution. We got one solution. When you solve the equation and you end up finding the value for the variable. A new case that we're going to talk about today is where you end up having no solution. When you solve the equation, the variable terms end up crossing out. When you take the baby bear, mama bear, you're going to see that they're exactly the same and they're going to cross out. And what you are left with is an unequal expression, which means it doesn't make sense, which means that there's no solution. And then the last case that we're going to talk about today is all real numbers. When you solve the equation, the variable terms cross out, meaning your baby bear and mama bear are the same, and you are left with the same constant term on both sides of the equal sign, which means that that makes sense. So I'm going to talk about each one of these cases throughout this presentation here. All right, so let's take a look at the first equation. All right, every time that we have an equation, we draw our line going down the middle. You see parentheses over here on the right side. So I'm going to distribute. And when we distribute, I take the 9 and I'm going to distribute it to the z and to the 3. That's the only first step I have to do. Now, if you take a look on the left side, I have 9z plus 12. And over on the right, I have 9z plus 27. I can't combine anything. But now this is my baby bear, mama bear step, right? Now this is a special case. I have 9z and I have a 9z on the right side. As you can see, the baby bear and the mama bear are the same. So should I take the 9z over to the right side, left side, or should I take the 9z from the left and take it to the right? Well, honestly, guys, it doesn't matter, okay? Because whether you take 9z to the left, 9z to the right, you're taking and they're going to both sides. So as you can see here, the 9z and the 9z cross out on the left and on the right. So now what happens here? Well, what happens is that I bring down, what I'm left with then is I bring down my 12 and I bring down my 27. So I'm left with 12 equals 27. Does this make sense? No. This is not a true statement. 12 does not equal 27. So what is our answer going to be? Our answer is going to be no solution. No number that I can put in will make the left side and the right side equal. Okay, 12 is not a solution. 27 is not a solution. What I write down and what you're going to select if you have this as a problem is you're going to select no solution. Okay, let's take a look at another example. So I have 20z or 20c plus 4 equals -4, parentheses, -5c minus 1. In this problem, first step that we're going to do on any problem is put your line going down through the equal sign. Okay, I see the parentheses, so that means I'm going to distribute. And what number am I going to distribute? Well, I'm going to distribute that -4. And I'm going to distribute -4 to the -5 and to the -1. And when I get that, I have my left side to be 20c plus 4 and my right side to be 20c plus 4. All right, well, on my left side, 20c plus 4 I can't do anything with. On my right, 20c plus 4 I can't do anything with. So now this is the baby bear, mama bear step. And as you can see, they're exactly the same. So should you take the left side and bring it to the right, or take the right and bring it to the left? Honestly, it doesn't matter because you're taking the same number to both sides, which is that negative 20c. You're taking negative 20c to both sides, which means that those are going to cross out. Okay. The 20c and the negative 20c on the left cross out, the 20c and the negative 20c on the right cross out, and I bring down my 4 equals 4. So now at this point, is this a true statement? The answer is yes, this is a true statement. 4 does equal 4. So then what is my solution? Well, my solution, I write down, and if I have a problem, I would write or select all real numbers. Now you might be thinking, well, what does all real numbers mean? In context to what we're talking about here, all real numbers means that every number on the number line, we can substitute in for the values for our variable. So again, what does this mean? What does all real numbers mean? All real numbers means that every number on the number line, we can substitute in for the value of our variables, and the left side and the right side will be equal. Okay, meaning I can put any number into my C that I want to. Any number on my right side, I could put any number inside there. I could put 1, I could put 10, I could put -6, I could put a 1/4. Any number on the number line, when I substitute it back into the value for the variable, it will make sense. And that is all numbers. Okay, so let's take a look at another example. All right, so I have 7w plus 1 equals 8w plus 1. First step, draw your line going down through the equal sign. Okay, now if you can look here, I didn't have to do the distributive property. There was nothing to combine on the left side or the right side, but what I could do is my baby bear and my mama bear step. Now, what we just did on those other special cases on the slide before, we took they were both the same. We had the 20Cs that were the same. We were able to have the same baby bear and the mama bear, which then canceled out. Here, that's not the case. This is what we did last week. So you're not all of your answers are going to be no solution or all real numbers. So you have to keep in mind that this is a special case. I mean, you're going to get an answer on this one. Okay, so I'm going to take the 7w over to both sides. Okay, when we do that, I bring down my 1. The 8w and minus 7w gives us the 1w, and then I bring down the 1. Okay, so you can't forget how to solve these equations still. So you're going to subtract 1 to both sides, and -1 and a +1, that's a 0. And you have to make sure you put that 0. -1 and a +1 cross out, because why do I cross it out here is because I want to get rid of that +1. So I make it -1 on both sides. I bring down that +1w. 1 times w means that that's multiplication, and to get rid of multiplication, I have to divide, and so you get your answer of 0. This is your answer, w equals 0. And if you substitute it back into your equation, the original equation, you will see that the left side and the right side are equal. Okay, this was not a no solution. This was not an all real numbers, because I was able to continue solving for that variable. My variable terms did not cross out. Okay, so let's take a look at a couple more here. All right, so first step, draw your line going down through your equal sign. As you can see, I have parentheses, which means I'm going to distribute. And when I distribute, I get 4n minus 8, and then I just bring down that -1. And then on my right side, then I just brought down everything. And if you notice here, my -n, I rewrote it as a -1n. That does help. Okay. So then on my left side, I do have some terms that I'm allowed to combine. I'm allowed to combine my -8 and a -1 on my left, and on my right, I can combine my variable terms, the 5n minus 1n. So what are we left with? So my -8 and -1 was -9, and 5n minus 1n was 4n. Okay, so as you can see here, I distributed, I combined my like terms, and now this is the baby bear mama bear step. Well, if you take a look closely, you have a positive 4n on the left and a positive 4n on the right. Which is your baby bear, which is your mama bear? At this point, you should say, well, they're both the same. They're going to cross each other out, which here's my next step. So I'm going to subtract 4n to both sides. And what am I left with? I am left with the -9 and a positive 9. As you can see, -9 does not equal 9. These are not equal to one another. So when your baby bear and your mama bear, when your variable terms cross out and they're no longer there, what are you left with when the equation does not make sense? It does not make sense. So the answer is no solution. Okay. If you need to stop and rewind this, go back through some of these examples, make sure you understand this. I do have about 4 more examples to go through with you here. Okay, so let's take a look at another one. I have 3x minus 5x minus 8 equals -2 parentheses x plus 4. So again, by this time you should be understanding what your first step is to do, which you're going to distribute. When you distribute on the right side, you get -2x minus 8. And I went ahead and just combined the 3x minus 5x on the left side. I just did that all in one step. So I have -2x minus 8 on my left side, and on my right side, I have -2x minus 8 on my right. Baby bear, mama bear step, take and get rid of your variable terms. As you can see, they are exactly the same. So it looks like I'm going to add 2x to both sides, and that gets rid of them. They're gone. I bring down my -8s on both sides. Does -8 equal -8? Is this no solution, or is this all real numbers? Or is my answer -8? My answer is all real numbers. Any number that I know of on the number line, I can substitute it back into the values for my variables, and it will make sense. That's what all real numbers means. There is an infinite amount of solutions there. Okay, let's take a look at another one. All right, so I have 24a minus 12 equals -4 parentheses 3 minus 6a. First step, draw your line going down. Let's distribute. So when we distribute, we're taking the -4 over. We're taking -4 times 3 and -4 times -6. When I do that, on my left side, I have 24a minus 12. And on my right, I have -12 plus 24a. Next step, baby bear, mama bear, because I can't combine anything else on my left side. I can't combine on my right side. So my next step is to get rid of those 24a's. Well, 24a and 24a looks like that they're the same, so I am going to take the -24a to both sides. And what happens when that occurs? They cross out. And then you bring down your -12s. All right, so -12 equals -12. And guys, you have to be very careful that you're bringing down on that left side that negative with it, because if you forget to do that, you're going to have 12 equals -12, which then you're going to put as the wrong answer. -12 equals 12, which means your answer is all real numbers. And as you can see, these two are exactly the same type of problem. You get the same answer on the left as you do on the right side. Okay, let's take a look at 2 more problems. All right. So let's look at number 7 here. Draw your line going down. We have a lot of distributing to do here over on the left side and on the right side. When I distribute, my problem now becomes 8x plus 16x minus 12 equals 24x plus 16 minus 2. At this point, I want to combine my like terms that I'm allowed to on my left side and what I am allowed to combine on my right side. On my left side, I can combine the x's, and on my right side, I'm allowed to combine my constant terms. When I do that, I end up with 24x minus 12 equals 24x plus 14. I can't combine anything else. So at this point, I am going to take my baby bear and my mama bear. Those are my variable terms. So I am taking 24x to both sides. But when you cross over the equal sign, you always have to take its opposite. So I make negative 24x. And as you can see, they cross out. And you bring down the negative 12 and you bring down the 14. And what happens here? I have negative 12 equals 14. That does not make sense. If it does not make sense, that is not a true statement. We write that the answer is no solution. No number there is not a single number that I can put back in that would make the left side and the right side equal. Okay, let's take a look at another one. One more. Line down through the middle. That really does help us to separate left side and the right side. Here I have two sets of distributive property two sets of distributive properties. So what I do is I get negative 20 plus 30x, negative 40x minus 20. And be careful, guys, with the positives and negatives, because let's say you mess up here and you wrote down a positive 20 instead of a negative 20, everything's going to mess up. So if you take a look and see what our next step is, which is to combine your like terms, I can combine negative 30x and a negative 40. And I can combine the 20 and the negative 20 and the negative 20. And then on the right side, I'm allowed to combine the negative 15x and the 45x. Okay, so what do we get there? So I got negative 10x because I took 30 minus 40x. That's where the negative 10x comes from. And then the negative 20 and negative 20 gives me the negative 40. And negative 15 and 45 gives me the positive 30x. And as you can see, I kind of went a little ahead of myself here. This is the baby bear mama bear step. Well, the baby bear mama bear step looks like I can actually do this one now. They're not going to cross out. I'm going to take that negative 10x over to the 30x. And when I take that over, and again, I made a little mistake on this one. That should be a positive 10x when I take that over. Okay, so when I take that over, I end up with negative 40 equals, and now since I made a mistake there, that should be a 40x. Okay, and then I need to divide by 40. Okay, so at this point, my problem is negative 40 equals 40x. Divide by 40, divide by 40. Those 40s cross out, and I am left with an answer of x equals negative 1. All right, so here I actually get an answer because I had different baby bear mama bears. I had different variable terms where I was allowed to take one to the other side. And when I did that, I am still left with the x, and x equals negative 1. Okay. Now, those are my examples that I had for you. If you need to go back through and rewatch this, please do so. But let's recap the special cases, okay? So there's 3 different cases. The first one is when you only get one solution. That's what we've been working up until this point, is when you solve the equation and you end up finding the value for the variable, you get an answer. So your answer would be example x equals 6, okay? Another special case that you get is when you end up having no solution as your answer. That's when you solve the equation and the variable terms end up crossing out and you are left with an unequal expression. So for example, your variable terms crossed out and you're left with 7 equals negative 10. Well, this is untrue, therefore that is no solution. And the last example that we have here is all real numbers. That's when you solve the equation and the variable terms cross out and you're left with the same constant term on both sides of the equation. So for example, you end up with, let me go back there. You end up with positive 10 equals 10. That means you have all real numbers as part of your answer. Okay. If you're on my Google slide presentation, you can click into this video, and there's another example that goes through different equations with all of the same special cases. Make sure you come to office hours if you need to, ask questions, email us, let us know what we can do to help you. Have a good day.